Good morning. Today we're going to start talking about proportional relationships. So we're taking what we've learned as far as constant of proportionality and unit rates, and we're putting it together with tables and graphs and equations, and we're going to learn a couple of more vocabulary words. Okay, so starting here, you guys have this notes page. Fill it in while we're going along. So proportional relationships always represent a constant rate of change, okay, which means the rate is changing at the same pace or the same speed or whatever it is we're talking about. It stays constant. So always forget to select the pen. Constant rate of change. The change remains the same or it's equal, which is that constant of proportionality. That's what the reason why we start with that is so that we can understand what a constant rate of change is. So when we divide it out, we get the same number over and over and over. All right, so two things will always be true about a graph that is proportional. We've already talked about this. So the graph will be a straight line. You guys remember that word linear. Okay, and the graph will pass through the origin. Okay, so in a table, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y divided by x will always be constant. Constant, and you guys can put that word equal. It's always going to be the same. Okay? If you need to, of course, you can always pause the video to fill your notes in. I'm going to go on to the next page, which is the example that we have. Okay, so the word problem says the number of miles a white-tailed deer travels is shown in the table below. Complete the missing information and answer the question. Okay, so we're looking at the table first because we have nothing else written on here, and we have at this point, we see, ooh, that's a little too dark. Let's try the other color. We see 3 and 84. So 84 miles in 3 hours. Okay, so we have to find K for that. And remember, we find K by taking y and dividing by x. Okay, remember, hours or the first column is always our x. Miles is going to be our y or our second column. So y divided by x, I'm going to take 84 because that's my value for y. I'm going to divide by 3. Okay, 84 divided by 3, we can punch that into the calculator. 84 divided by 3 is 28. Okay, so 28 is going to be my constant of proportionality, or my constant rate of change, because it is telling us this is proportional. Okay, so I'm going to take, and I'm going to fill that in. Remember, when we get this number, this is how much per 1, because it's also our unit rate. So 28 miles in 1 hour. Okay, we can double check that it's constant by using the 7. Oops, divided by 7. And again, we get 28. Okay, that's just a way to double check. So now we're increasing 28. Remember, 28 times 2. 28 times 2 is 56. Okay, we already have the 3 filled in. 4 is 112. 5 is 140. 168. 224. And 252. And remember, you guys, to find these numbers, you're just taking your constant and multiplying by each of the hours listed in our table. Okay? I'm just trying to save us a little bit of time. All right, so now I can take this information and graph it. Remember, we always graph x, then y. Okay, I'm not writing my coordinate pairs out, but you can if you need to. Okay, so I'm going to number my graph. I'm going to start with 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we have to pick an interval for our y-axis. And of course, this is x and this is y. Okay, so our y-axis, it's just going to be easier for us to stick with that constant of proportionality. Okay, we're going to number by 28. Okay, so 28, 56, 84, 112, 140, 168, 196, 224, and 252. All right, and then we're just going to take and plot these points on our graph. Okay, so first is 128, and you guys, if you want to draw your commas in between, oops, mine's really big, but draw your commas in between if you want to, because that will help you. Okay, remember I go x first, so I go to 1 and 28, 2, 56, 3 and 84, 4, 112, 5 and 140, 6, 168, 7, 196, 8, 224, and 9, 252. Okay, and then we can draw a line in. Okay. So now we have our line, and we're looking, so I can write my equation out now. Alright, so my equation for this, okay, I'm increasing by 28 each time. Okay, so I do have a constant of proportionality, so y equals 28. Remember, that's where our k is, x. Okay, because our standard equation, and I'm going to write it up here, is always y equals kx, where k is the only thing we put a number in. Okay. Now it's asking for a verbal description. This is kind of like writing a word problem. Okay, so for this one, we're talking about the white-tailed deer. So I should say a white-tailed deer. And what is he doing? He's traveling. So travels, okay, at a rate of 28 miles per hour. Okay. And then this last one's asking us, is this proportional? And if it is, what are the ways that we know? Okay, so the first thing is we know it's proportional because we have a constant rate. And then, of course, that's miles per hour. And that would be our K. Remember, he talks about that. All right. It's also, if we look at our graph, see how it's in a straight line. So we have a straight line, or it's linear. They mean the same thing. You can put either one. Okay, and if we continue down, it would pass through the origin. Ooh, can't spell. Let's try that again. Pass through the origin. Okay, so you guys, that's our example. You guys are doing exactly the same type of problem. I want you guys to do this one, and then also these problems. I'll do the first one with you right now. But what I want you to do is finish it up. That's what I want you to take a picture of and submit for your work today. Okay, I will also be assigning a Delta Math in a Khan Academy. Okay, Khan Academy is like your bell ringer, and then the Delta Math will be your second assignment for today. Okay, so this is telling us to read each scenario below, determine if the situation is proportional or not. If it is proportional, it is asking us to write an equation. Okay, so this first example, a restaurant charges $10 for medium pizza and $1 for each topping. Okay, one thing that we remember from looking at our proportional is that we have a constant rate of change, but there's nothing else added to the problem. If we were to write this one out, while we do have a constant rate of change, we're also adding that extra $10 in. Okay, if it was $10 per pizza or it was $1 per topping, it would be a constant of proportionality, but this one is not. So this one is not proportional, so we cannot write an equation. Okay. The next one, a restaurant has an all-you-can-eat buffet. They charge $8.75 per person. We have a rate per person. Regardless of how many people eat, you're going to multiply it by that $8.75. So we can write an equation for that. This is our constant of proportionality, or K. So we would write that out. Y equals $8.75 times x representing the number of people. Okay, so you guys try these next three, and then also the first page, or the first box on that page. Okay, if you have any questions, as always, I'm available by email. Zoom, I'm going to have to push it to about 2:05, but I'll be on from about 2:05 till about 2:30. So if you guys have questions, you can jump on and ask. Otherwise, I'll see you later. Have a good day.